Okay, um, math for college. We're looking at the quadratic formula today. This is the last lesson of your unit. So we're shoving this in kind of with the rest of the radicals because you have a radical involved here and you're used to simplifying it. But it does raise some question about quadratics, namely the shape of a parabola. And so what we have here is an example of, say, x squared minus 4x plus 3 is equal to 0. We talked about solving that by factoring x minus 3 times x minus 1. Now, the solutions to that are 3 and 1. What that actually looks like graphically is the parabola crosses through the x-axis at 1 and at 3. That's what it looks like graphically. And it was easy to find by factoring. But if we were to change that to something slightly different, x squared minus 4x plus 2. In that situation, we can't solve it by factoring. And when you can't solve it by factoring, instead you use the quadratic formula. Now, the most important part of the quadratic formula is what we call the discriminant. It's the part underneath the square root sign. And if the part underneath the square root sign, the discriminant, is positive, that means that there are two real solutions. So that means that the parabola would actually cross in two places. Those would be the two spots where it crosses the x-axis. If the value of the discriminant is 0, that means that there's one real solution. We call it a double solution, a double root. And that means that it just barely touches the x-axis and then goes back up at one spot. So that would be your solution. And if the value underneath the square root sign is negative, there are 0 real solutions. They're what we call two imaginary solutions. And what that means is the parabola never actually crosses the x-axis at all. See, it crosses the y-axis, but it does not cross the x-axis. So we're not going to graph anything today. I just wanted to build that in because we will talk about it later. Let's just find the value of the discriminant, then determine the number and type of solutions. So in this situation, we're just going to look at b squared minus 4ac. That's the part of the quadratic formula that's called the discriminant. A is 1, b is negative 6, and c is 9. So b squared is 1 minus 4 times a is 1. I'm sorry, I messed this up. B squared, that will be negative 6 squared minus 4 times a is 1 and c is 9. So negative 6 squared is positive 36. If you square negative, it's positive. Minus 36, and so you get 0. So that means that there's one real solution. In this situation, a is 2, b is negative 1, and c is negative 3. So we have negative 1 squared minus 4 times 2 times negative 3. 1 minus 4 times 2 is 8 times negative 3 is negative 24. You get 25. That's positive, so it means that there are two real solutions. Next example, we have a is negative 1, b is 1, and c is 2. So b squared minus 4 times a times c. 1 minus 4 times negative 1 is negative 4 times 2 is negative 8. So you can see you get 9. So there's two real solutions. A is 1, b is 4, c is 3. B squared minus 4 times a times c. So 16 minus 12. And we get 4. So that means that there are 2 real. Now that you understand the discriminant, let's work on simplifying our radicals that we get as a result. Sometimes you'll come up with expressions from your quadratic formula that end up like this. We're going to simplify this to 6 plus or minus. The square root of 24 can be simplified to square root of 4 times the square root of 6 all over 4. Square root of 4 is 2, so 6 plus or minus 2 roots of 6 all over 4. Notice that all of these are divisible by 2. So if you factor the 2 out of the top, you can divide by 2 on the bottom. You get 3 plus or minus the root of 6 over 2. The next one, 3 plus or minus the square root of 45 can be rewritten as square root of 9 times square root of 5 all over 9. So you have 3 plus or minus 3 roots of 5 over 9. Notice that these are all divisible by 3, and I get 1 plus or minus the root of 5 over 3. The next one, I have 6 plus or minus the root of 4 times the root of 5 over 12. Or 6 plus or minus 2 roots of 5 over 12. Notice how these all are divisible by 2. And so we get 3 plus or minus the root of 5 over 6. (12) plus or minus 54 is divisible by 9 and 6. So 12 plus or minus 3 roots of 6 over 4. 3, 12, and 4 are not all divisible by the same number. So you're done. Six plus or minus the root of 100 times the root of 2 over 10. 6 plus or minus 10 roots of 2 over 10. Notice that these are all divisible by 2. So we get 3 plus or minus 5 roots of 2 over 5. And finally, 20 plus or minus the square root of 4 times square root of 2, that's what the square root of 8 is, over 40. So 20 plus or minus 2 roots of 2 over 40. Notice that those are all divisible by 2. I get 10 plus or minus the root of 2 over 20. Now that we have the discriminant and we have the simplifying procedure, let's go ahead and solve using the quadratic formula. A is 1, B is -3, C is -18. Remember the formula is negative b plus or minus the square root of b squared minus 4ac all divided by 2a. I'm just going to write that there so I can keep it. You can just look at your sheet for it. So negative b would be positive 3 plus or minus the square root of b squared is 9 minus 4 times a is 1 and c is -18. All divided by 2 times a. 4 times -18 is -72. 9 minus -72 is positive 81. 3 plus or minus the square root of 81 over 2. Oh, my smartboard got a little upset in that step. Pause and we'll get back to it in just a second. All divided by 2. So we get 3 plus or minus. Notice you can take the square root of 81 to get 9 divided by 2. It's a perfect square root. Instead of simplifying it like we did above, just find the two results. Your two answers are 3 plus 9 divided by 2 and 3 minus 9 divided by 2. 3 plus 9 is 12 divided by 2 is 6. 3 minus 9 is negative 6 divided by 2 is negative 3. Those are your two answers, 6 and negative 3. Look at the next one. A is 2, B is negative 11, C is 5. 11 plus or minus the square root of 121 minus 4 times 2 times 5. Divided by 2a, which is 4. So we have 11 plus or minus the square root of 4 times 2 is 8, times 5 is 40. And 121 minus 40 is 81. Get that nice number 81 again, so it's 11 plus or minus 9 over 4. Since it comes out to be a perfect square, find those two numbers. 11 plus 9 divided by 4, and 11 minus 9 divided by 4. 11 plus 9 is 20, divided by 4 is 5. 11 minus 9 is 2, divided by 4 is a half. A is 2, B is negative 7, C is negative 5. Negative B would be positive 7, plus or minus the square root of. B squared is 49, minus 4 times A is 2, and C is negative 5. Divided by twice the A value. So we have 7 plus or minus the square root of 4 times 2 is 8, times negative 5 is negative 40. 49 minus negative 40 is 89. There is no square root of 89, and 89 cannot be simplified like we did up here. So therefore, this is your answer. This is what we call simplest radical form. The last result, A, B, and C. A is negative 1. B is negative 8. But C is not negative 4. You must have it written so it equals 0. Negative x squared minus 8x plus 4 is equal to 0. Notice how I move the 4 over. That makes the C a positive 4. Always set your equation equal to 0. That's the way the quadratic formula works. Negative b, so positive 8 plus or minus square root of. B squared would be 64 minus 4 times a is negative 1 times c is 4. All divided by 2a, negative 2. That'll be 8 plus or minus the square root of. We have 64 plus 16, which is 80. Now there is a square root of 80. Not a perfect square, but we can simplify it. It's the square root of 16 times the root of 5. So we'd have 8 plus or minus 4 roots of 5 over negative 2. Now, we're going to simplify this because the 8 and the 4 and the negative 2 are all divisible by 2. In fact, we're going to divide by negative 2. 8 divided by the negative 2 is negative 4. And then 4 divided by negative 2 is negative 2. Notice the plus and minus use up that sign for the negative, so you don't have to write negative again. It uses up also 2 roots of 5. And then negative 2 divided by negative 2 is 1, so we don't need to put anything in the denominator because we have a 1. So that's your simplest radical form. So there's your answers for the quadratic formula. A nice review. Good luck. We'll enjoy seeing you in class soon.